Okay, let me do a quick introduction to what the toner transfer method is for creating printed circuit boards. This is not complete. This is a quick and dirty presentation, and I will create a PDF file and I will put it on my web page. So here's my email address, and I reserve the right to ignore any stupid stuff. And below this is my home page, and you can go to the bottom and find this and probably the PDF file if you want to try this with my layout. So the toner transfer technique allows you to use a laser printer, create a PCB board, single layer PCB. You can do dual, but I've never done that, and I'm not interested. So let's look at what you're going to need. First of all, you're going to need some kind of project, and you're going to need a computer program to lay out the board. Or I remember Dave Benson, when he was in N1G, did his first NE 4040 and maybe something before that, just using a regular graphics program. That was before we had PCB layout programs with the compute power. You're going to need some printed circuit board material. I'm going to use 0.030 inch thick because, and I recommend you use it because it's thin. You can cut it with a heavy duty paper cutter shear, or you can use tin snips or some heavy duty cutting thing. Scissors, I don't recommend. Or if you've got one already, a shear. We're going to need some 3M, and I've got pictures of some of this stuff, a 3M heavy-duty stripping pads for cleaning boards and removing toner. We're going to need a laser printer. This process will not work at all with an inkjet printer because the print just washes away. I recommend you use laser gloss paper. Now, there are some people on the web, if you go and do some research, go and get slick pages out of catalogs and advertisement and stuff like that, and I don't consider that very smart. You've got a laser printer that costs you $100 or more, and you're going to put non-standard paper through it. Could cost you a printer. We need a laminator. And this is a little device that allows you to seal paper in plastic, but we're going to misuse the thing. Some people will use a clothes iron, but I don't like a clothes iron because it tends to cause the paper to shift on the printed circuit board, and you're going to ruin your registration on the layout. You're going to need a small plastic clamp because we're going to run the PCB through the laminator, and it's going to get up to 100 degrees Celsius. And for those of you who are not familiar, 100 degrees Celsius is 212 degrees Fahrenheit, and that's the boiling point of water. So if you want to handle something that is hot as boiling water, I don't recommend you trying this, or even being in the hobby. All right, we're going to use some hydrogen peroxide, 3%. I get this at a bottle of this costs $1.24 at Walgreens. You can get it off of Amazon. I'm sure you can get it at Walmart. Then we're going to need some muriatic acid. This is for swimming pool. It's 14.5% hydrochloric acid by volume, and you can get this in the swimming pool garden department of Home Depot. I bought 2 gallons. It came in a box manufactured by HDX, cost $15 and some change, less than $16. And this ought to be a lifetime supply. You're going to need a Pyrex dish. I use a 750 milliliter. I believe I got it at a dollar store. You're going to need a plastic measuring cup that's one quarter cup for measuring the hydrogen peroxide and the muriatic acid. We're going to use 2 1/4 cups of hydrogen peroxide and 1/4 cup of muriatic acid for the mix, and I'll refresh this. I like to use Krylon enamel clear to coat my board to keep it from tarnishing 10 years from now. You're going to need a mini drill press or a Dremel with a drill press attachment for drilling the holes in the printed circuit board. I recommend a momentary foot pedal from Amazon. I got mine for $7. And what this allows me to do is to set the drill press or the Dremel tool at the speed that I want to drill. Because they have a variable speed knob, you turn it off and then you turn it to the desired position. If you want to turn it off, you got to turn the knob again. This little foot pedal, and it's the one with the 3-prong plug, not the sewing machine that has a weird plug. You're going to need some silicon with some carbide drill bits. Got these off of Amazon. Set of 5 different sets of bits for under $20. And there's probably some other stuff, and I'll come back and refresh this later. Now, since we're going to do a project on printed circuit board, we need a printed circuit board material, and I recommend a vendor on eBay, ABC Fab. Now, this document has a link, so if I click on this, I'm supposed to click on it, and it's going to go to eBay, and here it is. Vendor's PCB laminates, copper clad. I'm going to go over here to the search, and this is search his items, and I'm recommended 0.030. 0.030. So let me search, and we get all these boards. It's copper clad circuit board laminate. It's FR4, which is flame retardant 4. It's an epoxy fiberglass substrate, and with copper on both sides. That's double-sided. The single-sided board, which is what we'd like to have, is more expensive. And this stuff, this is, go down here and find, here's 10 pieces of 3x4. That's a little too small. I recommend a 4x6. Here we go, 5 pieces is 14. You can get it cheaper if we get, let me find, I bought the 50 piece. There's a 24 pieces, 030, 4x6, 1 2-ounce or ½ ounce. That's probably a little thin on the copper. He changes things around. Oh, here we go. That's 4x5. That'll do. 25 pieces for $23.50. Free delivery is shipped USPS priority. And so this turns out to be, what? Less than $1 a board. 4x5, and I got 4x6. I got 50 pieces for a lot. Let's see here, $50 or something like that. Here's 50, 4x5 for 45. I'll let you look that up. Get 6 or 12 pieces if you're not sure you're going to stick with this. Now, so you get your board. Now, here's the stripping pads. I use this to clean the printed circuit boards and to remove the toner when we attach it to the board. Here's what a board looks like. This is maybe not the same. Well, it's just a board, and this one was an old board, and it's probably been abused by me. If you take the 3M pad and clean the board, and I just put, you got to do this outside, use a heavy duty glove to hold the board in place. Put it on I've got a 1/4-inch plywood board that I put this on, and then rub the pad back and forth with pretty good pressure and get it clean on both sides. Now we're going to laminate the circuit board layout using the toner off the printer onto the PCB, and we do it through this laminator. And this is an Amazon laminator called Amazon Basics. I just bought this thing in the last couple of weeks. It's $20 with free shipping if you're a Prime member. It's not what it's designed for, and it's going to sound terrible sometimes, but it works. And I had to get something that you could get because the old laminator I used is no longer available, and it was more expensive. So for $20, we're going to see how long this lasts. I got an infrared thermometer. This is one I got from Harbor Freight a long time ago because I'm going to monitor the temperature of the board when it comes out of the laminator. Here's the package of 50 FR4 030, 1 ounce on each side, 4x6. And Bill wrote thanks again on there because I've ordered boards before. Here's the board out. The lighting's terrible here, but it's 4x6 board. I'm going to print the layout. Let me skip down to the end of this document, show you what we're doing. I'm going to do for the first board here, I'm going to do this crystal fixture. Okay, this is G3UUR, and it's used to measure crystal parameters. It's just a simple circuit. You can find something as simple or simpler. Maybe just do a crystal oscillator, or just do an oscillator. Just find something that you're interested in, or try this. Okay, this has 2 NPN transistors. You're going to test different crystals. I have 2 jumpers here to put a variable resistor in place and out, and then a capacitor here in series with this. We'll short both of these, and this is just a regular Colpitts oscillator with an amp. And I've got 2 outputs here. One to measure the frequency of the crystal while it's oscillating with everything shorted, and then unshort the capacitor here, and I get another frequency out, and then you just go and find the article, or I'll point you to it later on. Then here, the voltage doubler rectifier outputs a DC voltage, which can be fed to a digital multimeter, or I'm going to use an analog meter to check the activity, but this is the circuit we're going to do. Okay, so I used my little computer program. I used a program called Sprint Layout. It's made, programmed and done by a company in Germany. I think it's 45 euros, may have gone up now with all the tariff wars and stuff. But anyway, I generated this layout, and I'll do a separate video on that. This is what it looks like, comes out of the printer. Now this 4x6 board is too large, so, and I haven't cleaned it yet. So what I do is I go and cut it, and this board layout here is 70 millimeters by 40. So this is slightly larger, but this is just demo. You cut the board to size, clean it, get it ready. Now what we're going to do is we're going to feed this board blank through the laminator, and I do this about 5 times until it gets up to about 80 degrees Celsius. Now because this gets hot, you're going to need one of these. This is a Harbor Freight clamp, but you can probably find something like this at the dollar store or whatever. And you're going to use it to latch onto the board when it's coming out the back, and then hold the board and reinsert it here. Now, one of the things that I've got to experiment with, and I'd like for you to experiment with, I did this board feeding it through the middle here. I may want to try doing one board about the same size at different ends of this entry, or do it, one side in the middle and right side back and forth. We're going to do this like 4 or 5 times through blank. Then you're going to put the image, PCB image, toner face down on the top of the board, line it up, hold it down, and then start feeding it through the laminator. Make sure it stays in line, because once it goes through, it's locked onto the board. You can go and remove it and redo it if you screw it up, so nothing lost. But anyway, go through here. I think I did this 5 times through here, got it up to 100 degrees, and when the final pass comes out, this is what it looks like. Now, the image doesn't show up too much, but if you can see this dark area here, that's the 40 by 70 millimeters. That's the toner. It's now glued or melted onto the board, and the outside edges here are loose. Now, before etching, what I've got to do is I've got to remove the paper. The way I do that is I put plain lukewarm water, not hot, because you might melt the toner, just warm enough to make this process go a little faster. Maybe I should try it with cold water one time and see if I get a better result. But I let this set for about 5 minutes or so, and you'll see this paper wrinkle, and you'll start to see the paper get saturated with water, and the toner will start to show through. You do that, and then pull it out of the water, and then peel the paper off. Now, do this carefully, and you're not, be gentle when you do this. You're not going to get all the paper off. There's going to still be a layer on there. So I put it back in the water and let it soak a little bit more, another few minutes, then take it out and use your thumb and rub some of the paper off. Just the important thing here is not to get all the paper off the toner, but to get the paper off the area that's going to be etched. Now, when you put this in an acid bath, it's going to etch away all the copper that's exposed, but not that is protected by the toner. Now, one of the things that happened here is, one, I did not allow my laser to warm up long enough. And as a result, I have some defects. See this little spot here? There's a little spots here, bare copper here. This end right here, which I don't know if I needed to do another turn. Maybe should have gone through another entry point on the laminator so I get more pressure here. Here's another defect. And I used to, eons ago, do something else with toner transfer, and I used a Sharpie to try to correct little errors. Doesn't work, or didn't work very well here. It did work some, but not completely. So I'll show you. Now, you get the board ready to etch. Now, you take the water, you take either another 450 milliliter Pyrex dish, or take the water out, get rid of it, and then put 2 1/4 cups of hydrogen peroxide in the dish. Okay, water first, then 1/4 cup of muriatic acid, and with a plastic spoon, gently mix it up so it's all thoroughly mixed, and then you gently slide the board into the bath. And the first thing you see is that the copper is going to turn kind of a brown, and that's caused by oxidation. The process of the peroxide plus the muriatic acid causes the layer to oxidize and dissolve into the bath, and this takes about 5 or 10 minutes. Now what I do is I take the spoon and I mix the water. Keep the spoon off the toner. I lift the edge up here a centimeter or 2 out of the water and let it drop back into the water. It doesn't splash because the other end of the board is still in the water, and it causes a wave to go across here. You can take the spoon and stir the water around the outside of the board. This will speed up the etching process. Now you're going to etch all this stuff that's not protected by toner, and the back side of the board is also going to be etched, and it's the part that takes the longest. What I do is spend a lot of time here until about half or 3/4 of this gets etched out here. It'll turn green. Use surgical gloves, lift the board out and turn it upside down, and now put it back in there so that the toner side is down, and then now stir the bath back and forth on the back side, and do this until all the copper is off the back, because if you don't, that'll cause shorts. Okay, once you do that, you take it out. Oh, and this is what your bath is going to look like. Now do this outside, or do this in an open area, because this generates chlorine gas, and these little bubbles, I guess, are either chlorine gas bubbles or whatever. And what I do is I do this outside, and then I pour this. Now, before you pour this into a container, and I have a large soda cup with a lid that I pour this into, and then I'm going to let it just sit around outside, away from pets, animals, critters, the wife, and just let it evaporate away, and then dispose of the residue. Some of you may want to try to use this again for a second board. I don't recommend it. I don't know if it'll work, but some people do, and you're on your own. Here's what the board, take the board out. Now wash it in water. Get all the acid off of it and everything with surgical gloves. This is what it looks like. And the little paths here is probably where I hit it with a spoon, okay? Then you take this out, again with a 3M pad. Oh, here it is. I hold the bubble. I hold the board up and backlight it, and then with a number 10 power, 20 power loop, examine this board very carefully for defects. Now, your first board or two will, you can see here where I tried with the Sharpie, didn't work here. There's still a couple of places here that etched through, but the important thing here is to check to make sure all these traces are contiguous and do not short to the ground plane. For leads of components that go into the ground plane, I use what is called a thermal pad. This, when you go to solder this, if this thing is fully coated or fully, if it's all copper It's going to take longer to heat up. All right. Now, one of the things I did here, and when I give you the PDF to print off, I'm going to change these two transistor. I just used the pads that were in the program for printed circuit boards. So two things, the holes maybe a little bit large, and then this is a tight configuration. But if you want to try this, it works just fine. All right. Next thing I do is take the board back to outside with a 3M pad, and I scrape off the toner. And this is what it looks like. Let me enlarge this just a little bit more. Now, there's some little artifacts here, and this is caused by the toner being a little loose, and it got partially etched, not all the way through. Just make sure you got a good toner. Here is close up here. Remember the little place where I used the Sharpie didn't quite work. This 2 flaked off, the numeral 2 here, etched through part of it, and that's because the toner was loose. So first board may not be perfect, but this is just fine. You'll see how clean the paths are, the gaps, no shorts. So this thing's going to work just fine. Now, we're going to go and drill it. First thing I do is I put painter's tape on the back side of the board because I don't want it scratched up. It's the side where the components are going to mount. So now this is on a 2x4, and this is a mini drill. I start out with a mini drill. These are the bits. This is a green one, which is 0.5 millimeter diameter. And I go and I drill. This is the first time I used these bits from Amazon. I wanted to check them out. Plus, I wanted to make sure I knew what I was doing. I drilled these 3 holes here, then took 3904 and inserted it through the back holes so that you can see how it mounts here. You can see that the holes are probably a little bit large, but in 30 years of drilling boards, I've never broke a bit, and I'm afraid that if I went the next size smaller, I might just break a bit, and I want to keep my record intact. This is plenty good for soldering, as you'll see. So I did that. So went back to the drill press, drilled the other transistor holes here, swapped out the bits, did a couple of more holes, and then popped the drive belt on the mini. It's a Harbor Freight mini drill, which they don't sell anymore, and the belt's not available from them. So I went on the internet and ordered one. It's on the USPS truck somewhere between California and here. But I went and drilled out the rest of the holes using a Dremel tool with a drill press. It's a Craftsman. Here's what the board looks like when you're finished. Now I did some large holes here for the 2.54 millimeter headers. I think the same size holes here for the trimmer resistor. Now, one of the nice things about this technique is if you've got some part that nobody else has, you can drill the holes to match the part. After that, let's see. Now we're ready to start mounting stuff. First thing I do is test the power supply. This is my 9-volt battery to a 2.5 4 millimeter male header, and then a female header here with the 2 wires going off the 9-volt battery. I use a 1N4148 for the reverse protection diode, and I used a 2K metal 1/4 watt and a high intensity LED. If you think 9 volt, just start off with 9 volts, and it's a rechargeable battery. It's close to maybe 8.5, and I drop, say, 0.7 of a volt here. I've got under 8 volts. This is 2 mils through this LED, and it's still bright. So you go and you mount all the parts. And so this is what the final thing looks like. Now, I didn't have a 500 ohm trimmer, but that's not a problem because I got the jumper here, and these are Berg, B-E-R-G connectors. You use those in computer in the old days for jumpering addresses of drives and stuff. But anyway, sort this out. This is the two jumpers. I've got both of them applied here, so this 47 picofarad cap is not in line. I use a half of an IC socket for my crystal holder. I love these things because of the pins hold this. Thing is working. I took it and attached the Rigol scope to the output here. And I get where's my card? Here's my card. I get 2.28 volt peak sine wave at 3.93 megahertz. This is a 3.9, you can see 3.93 ECS crystal made in China. This is one I just pulled out and it works fine. I took the digital multimeter, I measured the DC voltage out here with a scope, and it's 3.44 volts DC, so that's plenty to work with. So here's the bottom of the board with all the soldering. I messed up here. I clipped the leads on this 2.54 header, and I shouldn't have. And anyway, I'd resolder a couple of nasty things here, but the rest of it works out just perfect. Instead of drilling the 3 millimeter mounting holes here, I just got these. I got a set of 100 of these off of Amazon for next to nothing, and I'm going to use these as just, rubber feet for the final thing. Oh, here. Let me reduce the size on this thing. Needs to go smaller. Here you can see the board. I took the PDF file and I flipped it, and so it matches this board, and you can see where the toner allows the copper to remain. You can see the traces, the pads here that have soldered to them. And I found out I have a mistake here, but it didn't matter. I have these thermal pads. Some of the veins here aren't quite, but when I soldered it, that doesn't look like it soldered over, but at least 2 of them worked. So I know what to do for the next board. I'm going to change some things. I'm going to make these holes a little bit smaller, so the drill bit setters, I got every hole but maybe one of the transistor ones. I think it was this one was not dead center. The others, every hole on there is dead center. So that's the project. I want you to get excited about this technique because it is nice, and I'm going to go through Wes Hayward's experimental methods in RF design to do some circuits, and I'll share them with you. So hope you follow along. Let's see how long I took here. I took 34 minutes. Don't know if I could have made it shorter, probably, but hope you stuck all the way through here, and I will start the series. They'll be all labeled toner transfer projects with some number. And this will be number 001. Thank you for your time. Would like to see a like, share with your friends. If you have the capability, download the video, make notes, and go to my website and look for the manual. This is the evening of the 25th, so it'll be sometime tomorrow. I'm going to add some text, and we'll get started. This document will be a work in progress. Thank you, and see you on the other side.